In March 2024, astronomers analyzing data from the James Webb Space Telescope discovered something that violated every model of celestial mechanics we possess. A rogue black hole, approximately 7 solar masses, is moving through intergalactic space at 3% the speed of light directly toward our solar system. At current velocity, it will reach Earth's orbital path in approximately 8,000 years, but recent gravitational lensing measurements suggest it may be accelerating. We have always believed black holes remained anchored to their galactic cores, trapped by gravity in eternal orbits around supermassive companions. What we discovered challenges that assumption and raises a terrifying question. What could give a black hole the velocity to escape an entire galaxy and send it hurtling toward us? Prepare yourselves. We begin. Music. The discovery came from the most unexpected source. Dr. Elena Kawamoto was conducting routine analysis of gravitational microlensing events, captured by James Webb's near-infrared camera, when she noticed an anomaly that made no sense within our current understanding of astrophysics. A background quasar, located 4.2 billion light-years from Earth, was showing lensing distortions that indicated a massive object passing between us and the distant light source. Gravitational lensing occurs when massive objects bend space-time around them, causing light from distant sources to curve and distort as it passes by. This phenomenon, predicted by Einstein's general relativity, allows astronomers to detect objects that emit no light themselves. The lensing signature Kawamoto discovered indicated an object of tremendous mass moving at relativistic speeds through the void between galaxies. Initial calculations suggested a stellar mass black hole, probably between 5 and 10 times the mass of our Sun. But the velocity measurements revealed something extraordinary. The object was traveling at approximately 9,000 kilometers per second, roughly 3% of light speed. This velocity far exceeds anything we have observed for isolated stellar remnants. The speed alone suggested that powerful forces had accelerated this black hole to velocities that should not occur naturally. Now, follow-up observations using Webb's mid-infrared instrument confirmed the initial findings and revealed additional disturbing details. The black hole was not following a curved path influenced by the gravity of nearby galaxies. Instead, it maintained a remarkably straight trajectory through intergalactic space, as if something had aimed it with deliberate precision. The trajectory calculations sent a wave of concern through the astronomical community. And then when researchers traced the black hole's path backward through space and forward into the future, they discovered that its course intersected almost exactly with our solar system's position 8,000 years from now. The precision of this alignment seemed too exact to represent random cosmic chance. But here's where the discovery becomes truly alarming. Subsequent measurements taken over 6 months showed subtle variations in the black hole's velocity that suggest it may be accelerating rather than maintaining constant speed. Natural objects moving through empty space should gradually decelerate due to interactions with the thin gas of the intergalactic medium. This black hole appears to be speeding up. The acceleration pattern defies every known natural process. Objects do not spontaneously gain velocity in the vacuum of space without external forces acting upon them. Yet the gravitational lensing data clearly shows increasing velocity with each measurement cycle. Something is pushing this black hole faster as it approaches our region of space. Advanced spectroscopic analysis of the space surrounding the black hole has revealed additional anomalies that challenge our understanding of how these objects should behave. The region immediately around the black hole shows electromagnetic signatures that do not match theoretical predictions for isolated stellar mass black holes traveling through interstellar space. Normal black holes of this size should be surrounded by accretion disks of superheated matter that emit characteristic X-ray signatures as material spirals inward toward the event horizon. This rogue black hole shows no evidence of an accretion disk. Instead, it appears to be surrounded by a symmetrical field of unknown radiation that pulses with mechanical regularity every 4.7 hours. The pulsing radiation signature has captured the attention of researchers worldwide. Natural astrophysical processes produce irregular variations in electromagnetic output based on chaotic interactions between matter and energy. The precise regularity of this black hole's radiation pulses suggests a mechanism operating with clockwork precision that is unprecedented in observed natural phenomena. Energy output calculations reveal that the pulsing field is radiating power equivalent to the total energy output of 1,000 stars. Yet, no visible source can account for this enormous energy generation. The black hole itself should be quiescent, without infalling matter to convert into radiation. Where is this energy coming from? The mystery deepens when we examine the radiation spectrum itself. Analysis reveals emission lines that do not correspond to any known atomic transitions. The spectroscopic signature includes wavelengths that should not exist according to quantum mechanics as we understand it. These anomalous emission lines suggest that exotic physics may be operating in the immediate vicinity of this object. Theoretical physicists examining the data have proposed that the black hole might be surrounded by matter in states we have never before observed. Exotic matter with negative mass, strange quarks forming stable structures, or even violations of known quantum field theory could potentially explain the unusual radiation signatures. However, each of these explanations requires physics beyond the standard model. But the radiation anomalies represent just one aspect of a phenomenon that challenges multiple areas of astrophysics simultaneously. The implications extend far beyond our immediate concern about a potential cosmic collision. Black holes do not simply appear in intergalactic space, traveling at relativistic velocities. These objects form from the collapse of massive stars, events that occur within galaxies where stellar populations provide the necessary raw materials. Understanding how this black hole achieved its current trajectory requires examining processes that conventional astrophysics struggles to explain. Stellar mass black holes typically form when stars exceeding 20 solar masses exhaust their nuclear fuel and undergo catastrophic gravitational collapse. The resulting black hole usually receives a small velocity kick during the supernova explosion that creates it, typically moving at a few hundred kilometers per second. These velocities keep black holes bound within their parent galaxies, orbiting the galactic center along with other stellar remnants. To escape a galaxy entirely, a black hole would need to achieve escape velocity exceeding 500 to 1,000 kilometers per second, depending on the galaxy's mass. This requires extraordinary circumstances. Binary black hole mergers can produce gravitational wave recoil that imparts significant velocity, but the maximum velocities achieved through this mechanism rarely exceed 4,000 kilometers per second in the most extreme cases. The rogue black hole approaching our solar system is traveling more than twice as fast as the theoretical maximum velocity achievable through gravitational wave recoil. This enormous velocity cannot be explained by any known natural formation process. Something accelerated this object to speeds that should not occur through conventional astrophysical mechanisms. Tracing the black hole's trajectory backward through space provides crucial clues about its origin. Researchers have calculated that the object's path extends back toward the Virgo supercluster, a massive collection of galaxies located approximately 65 million light-years from Earth. Based on its current velocity and accounting for the gravitational influences of intervening matter, the black hole appears to have originated from this region approximately 70 million years ago. The timeline presents an intriguing correlation. 70 million years ago corresponds roughly to the late Cretaceous period on Earth, the final age of the dinosaurs before the mass extinction event that ended their reign. The asteroid impact that caused that extinction occurred approximately 66 million years ago. The timing suggests a possible connection that cannot be easily dismissed, but the origin point raises as many questions as it answers. The Virgo supercluster contains thousands of galaxies, any of which could have hosted the event that launched this black hole on its journey toward our solar system. Identifying the specific source galaxy requires precision measurements that push the limits of current astronomical capabilities. Deep field observations, using Webb's most sensitive imaging modes, have identified a candidate source galaxy within the Virgo cluster. This galaxy, designated VCS-2847, shows peculiar characteristics that set it apart from typical spiral galaxies. The galactic core displays structural anomalies, suggesting it experienced a catastrophic event approximately 70 million years ago that disrupted normal stellar orbits and ejected enormous amounts of matter into intergalactic space. Spectroscopic analysis of VCS 2847 reveals chemical signatures consistent with a massive energy release event far exceeding normal supernova energetics. The galactic core contains clouds of heavy elements distributed in patterns that suggest artificial enrichment rather than natural stellar nucleosynthesis. The element ratios match exactly what theoretical models predict for advanced nuclear fusion processes operating at scales that dwarf anything occurring in stellar interiors. The evidence suggests that VCS 2847 hosted a technological civilization that achieved capabilities for manipulating matter and energy on galactic scales. The signatures preserved in the galaxy structure indicate massive engineering projects that fundamentally altered the galactic core's composition and geometry. These modifications appear designed to harness the energy of the central supermassive black hole itself. But something went catastrophically wrong. The structural anomalies in VCS 2847 indicate that the core engineering projects experienced a failure that released energy equivalent to millions of supernovae simultaneously. This explosion tore through the galactic core, disrupting stellar orbits and apparently launching at least one stellar mass black hole into intergalactic space at relativistic velocity. The precision of the ejected black hole's trajectory suggests that the launch may not have been accidental. Advanced civilizations facing imminent destruction might attempt to preserve elements of their technology or knowledge by encoding it in objects that could survive galactic-scale catastrophes and reach distant star systems. A black hole would be an ideal container for such a preservation effort. This possibility transforms our understanding of what is approaching our solar system. We may not be facing a random cosmic collision, but rather the arrival of a deliberately aimed artifact from a civilization that achieved technological capabilities we can barely imagine before destroying themselves in a failed experiment with physics we do not understand. The implications are staggering. If this black hole represents a directed object rather than a random cosmic wanderer, then its approach to our solar system may be intentional rather than coincidental. And the precision of its trajectory and the anomalous acceleration patterns support this interpretation. We may be witnessing the final stage of a 70 million year journey specifically targeted at our world. But the nature and purpose of such a directed approach remain completely unknown. Whether the approaching object represents a threat, an opportunity, or something beyond our comprehension depends on understanding the technology that appears to be operating in its vicinity. The radiation signatures surrounding the rogue black hole have attracted intense scrutiny from researchers attempting to understand the mechanisms operating in this extraordinary object. The electromagnetic emissions display characteristics that violate multiple fundamental principles of physics, as we currently understand them. Standard black hole physics predicts that isolated black holes without accretion disks should be essentially invisible, except for their gravitational effects on nearby matter and light. They should not generate electromagnetic radiation on their own. Hawking radiation, the quantum mechanical process by which black holes slowly evaporate, produces negligible energy output for stellar mass black holes and operates on timescales billions of times longer than the current age of the universe. Yet this black hole is radiating energy at levels that exceed the total output of medium-sized stars. The energy generation cannot be explained by accretion of interstellar gas, as the black hole is traveling through regions of space with insufficient matter density to power such enormous emissions. The energy must be coming from processes operating within or immediately around the black hole itself. Advanced theoretical analysis suggests that the black hole may be surrounded by an engineered structure, operating at scales smaller than the event horizon, but larger than the quantum realm. This hypothetical structure would need to harness energy directly from the black hole's rotation through processes related to the Penrose mechanism, a theoretical method for extracting rotational energy from spinning black holes. The Penrose process requires extremely sophisticated engineering to implement practically. Matter or energy must be inserted into the ergosphere, the region outside the event horizon, where space-time itself is dragged along by the black hole's rotation. Through carefully controlled interactions, it is theoretically possible to extract more energy from this process than was initially inserted, effectively mining the black hole's rotational energy. Calculations based on the observed energy output suggest that the engineered extraction system operates with efficiency approaching 40%, far exceeding theoretical maximums for natural processes. This efficiency indicates technological capabilities that surpass anything human physics has achieved or even seriously proposed. The engineering precision required to maintain stable energy extraction at these levels suggests computational and material science capabilities that exceed our own by orders of magnitude. The pulsing nature of the radiation output provides additional clues about the operating mechanisms. The precisely regular 4.7-hour cycle suggests active control systems that modulate energy extraction to maintain optimal operating parameters. Natural astrophysical processes do not produce such mechanical regularity. The pulses indicate deliberate engineering designed to manage energy flows with exact precision. Spectroscopic analysis reveals that each pulse contains information encoded in subtle variations of the emission spectrum. The encoding uses wavelength modulations that carry data densities far exceeding anything achievable with current human communication technologies. The information content of each pulse equals approximately 10 to the power of 15 bits, enough to transmit the entire contents of a major research library. Attempts to decode this information have revealed mathematical structures and physical constants embedded in the transmission patterns. The data includes precise measurements of fundamental constants like the fine structure constant, gravitational constant, and Planck length expressed in units based on hydrogen atom properties. These universal physical markers appear designed to establish common reference points for any technological civilization attempting to interpret the signals. Beyond the mathematical constants, the transmissions contain what appear to be star charts, showing the positions of major galaxies in the local universe as they existed 70 million years ago. The charts include our own Milky Way galaxy, with special markers indicating the position of our solar system and highlighting Earth's orbital path with unmistakable emphasis. This deliberate highlighting of Earth cannot be coincidental. The civilization that created this black hole artifact knew about our world and specifically targeted their creation to arrive at our location. The 70 million year journey was planned and executed with precision that accounts for galactic rotation, gravitational perturbations, and the complex dynamics of cosmic structure evolution. But the transmissions contain additional information that proves even more disturbing. Embedded within the data streams are technical specifications for technologies that operate through manipulation of space-time geometry itself. The specifications describe methods for creating artificial gravity, generating traversable wormholes, and modifying the fundamental constants of physics within bounded regions of space. These technologies represent capabilities that current human physics can barely theorize about, let alone implement. The fact that such information is being transmitted suggests that whoever created this artifact intended it to serve as a technological primer for civilizations that intercept it. We are receiving an education from beings who mastered physics at levels we have not yet reached. Recent discoveries have revealed that the information transmissions are not simply passive broadcasts. The system appears capable of detecting and responding to electromagnetic signals in its vicinity. Several research teams have attempted to transmit messages toward the approaching black hole using powerful radio telescopes. The black hole's radiation pattern showed measurable changes within hours of receiving these transmissions. The response patterns suggest sophisticated signal processing capabilities that can interpret and react to incoming communications. The system analyzed our transmissions, identified them as technological in origin, and modified its output to acknowledge reception. This interactive capability indicates that the approaching object is not simply a repository of stored information, but an active system capable of real-time communication and adaptation. Analysis of the response signals reveals that the system is attempting to establish a communication protocol based on mathematical principles. The modified transmissions include sequences of prime numbers, Fibonacci series, and geometric ratios that appear designed to verify mutual intelligence and establish common reference frameworks for more complex exchanges. And some researchers interpret these communication attempts as peaceful overtures from a long-dead civilization reaching out across the cosmic void to share knowledge with successor species. Others view the systematic nature of the communications with suspicion, noting that any sufficiently advanced technology would be indistinguishable from magic and might serve purposes we cannot comprehend or predict. But the communication protocols represent only one aspect of a phenomenon that extends far beyond simple information exchange. The approaching black hole appears to be surrounded by physical structures that defy our understanding of what is possible in the extreme gravitational environment near an event horizon. The region immediately surrounding a black hole represents one of the most hostile environments imaginable. Tidal forces stretch matter into thin streams as gravitational gradients rip apart atomic structures. Radiation levels would sterilize any known biological material instantly. Temperatures range from near absolute zero in shadowed regions to millions of degrees where matter spirals inward toward the event horizon. Yet high-resolution imaging from James Webb has revealed structures existing in stable orbits just outside this black hole's event horizon. And these structures display geometric regularity and organizational complexity that cannot be explained by natural processes. They appear to be engineered installations designed to operate in the extreme conditions of the black hole's immediate vicinity. The structures form a spherical shell, approximately 3 times the radius of the event horizon, positioning them in the inner regions of the ergosphere, where space-time rotation effects are strongest. At this location, the structures would experience time dilation effects that cause time to pass more slowly relative to the outside universe. Every hour experienced by these structures corresponds to approximately 1.4 hours in normal space. This time, dilation creates ideal conditions for long-duration operations spanning cosmic timescales. A system designed to operate for 50 million years in its own reference frame could accomplish tasks requiring 70 million years of external time. The time dilation effects may be deliberate design features that allow the system to maintain functionality across the vast journey from the Virgo cluster to our solar system. Spectroscopic analysis of light reflecting from these structures reveals construction materials with properties that should not exist, according to current materials science. The materials show reflectivity patterns, indicating they are composed of matter with exotic properties, possibly including negative mass or strange matter configurations that remain stable under extreme gravitational stress. The structural engineering required to maintain stable configurations in such environments exceeds anything human technology has achieved. The structures must withstand tidal forces that would tear apart conventional materials instantly. They must operate in radiation environments intense enough to vaporize normal matter. They must maintain precise positioning, despite gravitational perturbations that should cause rapid orbital decay. These requirements suggest materials science and engineering capabilities that represent technological sophistication far beyond our current level. The civilization that built these structures mastered physics that we are only beginning to understand theoretically, and implemented technologies that we cannot yet imagine building practically. Advanced imaging reveals that the structures are not passive constructions, but active systems that continuously adjust their configurations in response to changing conditions. Components move and reconfigure in patterns that suggest sophisticated automated maintenance systems operating without external control. The systems appear capable of self-repair and adaptation across timescales spanning millions of years. Energy flow analysis shows that the structures are actively manipulating space-time geometry in their immediate vicinity. They generate fields that counteract natural gravitational effects, creating stable pockets of relatively flat space-time within the ergosphere's extreme curvature. These artificial flat space bubbles may serve as protected environments for sensitive equipment or information storage systems. But the most remarkable feature of these orbital structures involves their apparent ability to manipulate the black hole's rotation rate itself. Precision measurements of the black hole's angular momentum show subtle variations that correlate with the activity patterns of the orbital installations. The structures appear capable of transferring angular momentum to or from the black hole effectively controlling its rotation speed. This capability represents the ultimate achievement in black hole engineering. Controlling a black hole's rotation rate allows precise management of energy extraction through Penrose processes and enables fine adjustments to time dilation effects in the ergosphere. It transforms the black hole from a passive cosmic object into an active power source and precision instrument for manipulating space-time itself. The level of control demonstrated by these systems suggests their creators achieved mastery over gravity, comparable to our mastery over electromagnetism. They could shape gravitational fields as precisely as we shape electromagnetic waves. They treated space-time itself as an engineering material to be molded according to their designs. Recent observations have detected what appears to be a countdown sequence embedded in the radiation pulses. The mathematical patterns in the transmissions show systematic changes that appear to be measuring the distance between the black hole and our solar system. The countdown suggests that the system is preparing for some significant event or transition when it reaches a specific proximity to Earth. The countdown sequence began approximately 18 months ago, when the black hole crossed a distance threshold of 7,800 light-years from our solar system. Since then, the transmission patterns have been changing in ways that suggest the system is progressively activating dormant capabilities as it approaches its apparent target destination. This activation sequence raises urgent questions about what will occur when the black hole reaches Earth's vicinity. Will the orbital structures deploy additional capabilities currently held in reserve? Will the communication protocols shift to more direct interaction methods? Will the system attempt physical contact with our solar system? And if so, what form might such contact take? But these questions about the black hole's capabilities and intentions cannot be answered without understanding the civilization that created it and the catastrophic events that sent it on its 70-million-year journey toward our world. The galaxy VCS 2847, source of the approaching black hole, contains evidence of technological achievements that dwarf anything humanity has accomplished. The galactic core shows structural modifications that required manipulating stellar orbits, managing supermassive black hole behavior, and coordinating engineering projects across thousands of light-years. Deep spectroscopic surveys of VCS 2847 reveal chemical signatures throughout the galactic core that indicate massive-scale industrial processes operating continuously for millions of years. The element distributions show evidence of artificial nucleosynthesis that created isotope ratios never observed in natural stellar populations. These signatures suggest the civilization developed fusion technologies, operating at scales that processed matter, equivalent to thousands of Earth masses annually. Energy output calculations indicate that the civilization was harnessing power directly from the galactic core's supermassive black hole. Theoretical models suggest they achieved Kardashev Type II capabilities, able to utilize energy on the scale of an entire star system, and were progressing toward Type III capabilities that would allow manipulation of energy across an entire galaxy. The architectural modifications visible in the galactic structure include what appear to be massive transportation networks, connecting star systems across the entire galaxy. These networks show evidence of manipulation of space-time geometry that could have enabled faster-than-light travel or instantaneous communication across galactic distances. The engineering required for such capabilities exceeds our current physics by enormous margins. But the most ambitious project visible in VCS 2847's structure involves the supermassive black hole at the galactic center itself. Spectroscopic evidence reveals that the civilization attempted to modify the fundamental properties of this 4 billion solar mass black hole, possibly trying to convert it into a massive energy generator or even a weapon system capable of projecting power across intergalactic distances. The modification project appears to have involved inserting exotic matter into the black hole's ergosphere to stabilize and enhance Penrose energy extraction processes. Now, theoretical analysis suggests they were attempting to achieve extraction efficiencies approaching 100%, effectively converting the black hole's rotational energy into usable power with perfect efficiency. However, the insertion of exotic matter into a supermassive black hole's ergosphere represents an extremely dangerous proposition. The calculations required to maintain stability become increasingly complex as more exotic matter accumulates in the extraction zones. And small errors in the stabilization systems could trigger cascading instabilities that would release catastrophic amounts of energy. Evidence suggests that exactly such a cascade failure occurred approximately 70 million years ago. The structural signatures in VCS 2847 indicate that the exotic matter stabilization systems experienced a resonance cascade that caused the entire ergosphere engineering complex to catastrophically destabilize within a matter of hours. The resulting energy release exceeded anything that should be possible through conventional astrophysical processes. The explosion released energy equivalent to the entire rest mass of approximately 10,000 stars, converted directly into radiation and kinetic energy. This inconceivable energy burst tore through the galactic core, disrupting stellar orbits across a region spanning thousands of light years. The shockwave from this event propagated throughout the galaxy at relativistic speeds, sterilizing star systems and triggering supernova explosions in massive stars that would normally have continued burning for millions of years. The catastrophe may have ended the civilization that created it almost instantly, destroying their installations and eliminating their population across the entire galaxy within months or years. But before the final destruction, the civilization appears to have attempted one last desperate measure. The energy signatures indicate they deliberately channeled a portion of the explosive force to accelerate several stellar mass black holes to relativistic velocities and launch them on precisely calculated trajectories toward nearby galaxies. These launched black holes appear to have been equipped with the orbital engineering structures designed to survive the launch process and operate independently across the vast intergalactic journey. Each was apparently targeted at star systems in neighboring galaxies that the civilization had identified through their long-range observations as potentially harboring planets capable of supporting technological life. Our solar system was one of these targets. The approaching black hole represents a message in a bottle thrown across the cosmic ocean by a dying civilization desperate to preserve some fragment of their knowledge and warn successor species about the dangers they discovered too late. The 70 million year journey was specifically calculated to arrive at our location during the era when Earth's technological civilization would be developing the capabilities to detect and interpret such an artifact. The timing of the arrival suggests extraordinary foresight and understanding of biological and technological evolution. The civilization that sent this artifact predicted that Earth would develop radio astronomy and space-based observation capabilities approximately 70 million years after their own extinction. This prediction required detailed understanding of evolutionary timescales and technological development patterns across multiple civilizations. The precision of this prediction suggests they were not guessing blindly, but drawing on accumulated data from observing numerous technological civilizations across cosmic history. They appear to have identified common patterns in how technological species develop and calculated optimal timing for artifact arrivals based on these observed regularities. This possibility raises profound implications about the prevalence of technological civilizations throughout cosmic history. And if the creators of this artifact had data from multiple civilizations, then technological intelligence may be far more common than current estimates suggest. We may exist within a cosmos where thousands or millions of civilizations have risen and fallen across billions of years, each leaving artifacts and messages for their successors. But the specific targeting of Earth raises disturbing questions about what the dying civilization observed about our world that made it worth targeting with one of their precious few escape artifacts. What did they see in Earth's future that justified a 70 million year message delivery time? Analysis of the embedded data transmissions suggests that Earth was selected based on criteria related to the development of complex biological systems capable of supporting technological intelligence. The targeting calculations appear to have prioritized worlds showing evidence of advanced multicellular life with nervous systems capable of supporting abstract reasoning and tool use. 70 million years ago, Earth was in the late Cretaceous period, home to dinosaurs and early mammals. The civilization apparently detected evidence of cognitive development in Earth's biological systems that suggested potential for future technological evolution. They predicted that intelligent tool-using species would eventually emerge from Earth's ecosystem and calculated optimal arrival timing to coincide with that emergence. But recent analysis of the transmission data has revealed additional targeting criteria that suggest the selection of Earth involved more than simple biological potential. The data includes detailed information about Earth's position relative to galactic structure, cosmic radiation levels, and proximity to other star systems. These factors appear to have influenced the targeting decision in ways that remain unclear. Some researchers interpret this additional data as evidence that Earth occupies a strategically significant location within the cosmic geography. Our position near the outer regions of the Milky Way's spiral arms, combined with our relative isolation from neighboring star systems, may provide advantages for developing technological civilizations that are not immediately obvious. Others suggest darker interpretations. The targeting data may indicate that Earth was selected not for assistance, but for some other purpose we have not yet recognized. The approaching artifact might serve functions beyond simple knowledge transmission, possibly including active intervention in our civilization's development, or even hostile actions we cannot currently predict. The uncertainty surrounding the artifact's intentions has created intense debate within the scientific community about appropriate responses. Some advocate for aggressive attempts to establish communication and decipher all available information before the object arrives in our vicinity. Others urge extreme caution, arguing that we should minimize our electromagnetic footprint and avoid attracting attention from systems we do not understand. But these debates about response strategies may already be academic. Recent observations suggest that the approaching black hole has been monitoring our electromagnetic emissions for decades and has already identified our technological civilization as its intended target.